Alright, so I actually rewrote some stuff on a separate sheet of paper to allow me to give a little bit more room from that first video. So moving forward, like we just talked about, so to get your denominators to match, you have to find the missing part. So in this case, because the x plus 2's match, we're missing the x minus 2, top and bottom, we have to multiply by that missing piece. Over here, the x plus 2 and x minus 2 match, but we're missing that middle x plus 2, so we have to multiply top and bottom by the piece that we're missing. Then we can just combine pieces. So the x minus 2 times x plus 1, and then in this case we get 2 times x plus 2. Now at this point, because we're subtracting fractions, we can't cancel out the pieces that we have here. Because if you just cancel out this x minus 2 and this x minus 2, we're going to end up with fractions that don't have the same denominator anymore. So the idea is we're not simplifying until the very end. So now we're going to subtract. So before we do that, we still have a couple more steps. So if we go through and we FOIL and multiply these numbers out, we're going to get, so we're going to actually FOIL this numerator, and we're going to distribute this numerator, and then we're going to combine your like terms. So if we go through and FOIL, x times x is x squared, positive x minus 2 is a minus 1x, and then negative 2 times positive 1 is a minus 2, all over that same denominator, that least common denominator that we got from before, minus, we still have that same least common denominator from before for both fractions. And if we distribute this 2, we get 2x plus 4. So now we can take our entire numerator and we can combine our like terms. But just remember, we're subtracting this whole group up top. So since we're subtracting this whole group up top, if we rewrite this numerator, we actually should get x squared minus x minus 2 minus 2x minus 4. Because this negative gets distributed to both terms. So make sure you don't forget that. We didn't have to worry about that when we were adding, but we definitely have to worry about that when we're subtracting. And again, once you guys combine all your numerators, it's still over that new denominator. And once we get that over your new denominator, we can combine your like terms. So there's no other x squared up top, so we get x squared. Negative 1x minus 2x is a negative 3x. Negative 2 minus 4 is a minus 6, all over x plus 2, x plus 2, x minus 2. And that becomes your final answer. You could also rewrite this and leave it as x squared minus 3x minus 6 over x plus 2 squared times x minus 2. And we can leave that for right now, just like that, as your final answer. So that takes care of example 3. So let's move on to this idea of complex fractions, okay? Complex fractions. So in the next piece of your notes, a couple key things that we're going to want to talk about. So a complex fraction is just what it sounds like. It's a fraction that contains a fraction in its numerator and denominator, or your denominator, I should say. So a complex fraction, just like you can kind of see in example 4 down below, has a fraction in the numerator and a fraction in the denominator. So there's a couple steps that we have to follow in order to be able to simplify a complex fraction. So to simplify a complex fraction, there's 2 steps. The first is we want to write its numerator and its denominator as a single fraction, if we can. All right. Then step 2 is we're going to divide by multiplying by the reciprocal of the denominator. So let's put this into practice for example 4. So the first thing we're going to do, and I gave you guys a lot of space in example 4, so we can get our numerator down to a single fraction and our denominator down to a single fraction. So in example 4, our numerator, lucky enough, is already in a single fraction. We're not adding or subtracting a fraction to another fraction like we are in the denominator here. So for this numerator, we're actually going to leave the numerator 2 divided by x plus 2 is actually going to stay the same because it's a single fraction. Our denominator, however, has 2 fractions that are part of it. So I'm going to go down here and rewrite both your fractions in the denominator piece. Okay? And we're going to do the exact same thing that we did in the previous examples. So we're going to start off noticing that these 2 fractions cannot simply be added together because they have different denominators. Since they have different denominators, the first thing we have to do is we have to find the least common denominator that is part of both of these fractions. Okay? So both of these fractions, both of these denominators have to be present in your new denominator. So since x plus 2 needs to be part of your original, or part of your new fraction, your new denominator, x plus 2 is going to be part of it, as well as x. So we could actually rewrite this as x times x plus 2, and this is your new denominator. Okay? So what we have to do next is we have to rewrite both of your fractions. I'm going to write them with spaces in between. We want to rewrite both these fractions to be x plus 2. So we want to change your first fraction denominator to be this. We want to change the second denominator to be this. So starting out, since x plus 2 is part of this denominator, what's missing from here that's part of the denominator down here is x. So I have to multiply top and bottom by the x that it's missing. So x times this group gives me my new denominator. So x times 1 gives me x. Plus, well, x is part of this denominator. What's missing from top and bottom here is the x plus 2. These two together give me my new denominator. My new numerator is 2 times x plus 2. So the next thing I'm going to do is I'm actually going to distribute that 2 and then combine terms. So my new numerator, because I'm adding, is going to be x plus 2 times x, which is 2x, and 2 times positive 2 is a positive 4, all over x times x plus 2. When I add it all together. If I go through now and combine my like terms, 1x plus 2x gives me 3x plus 4 all over x times x plus 2. And that becomes my new denominator. So I'm not completely done yet. I just found my new denominator when I combined both of those original fractions. So the next and last step is to go back up to the top, and I'm going to leave my denominators in groups. I'm not going to multiply this out. I'm going to keep them in groups because hopefully at some point they're going to cancel out. So up at the top, I'm going to rewrite my numerator as the exact same thing I had before, divided now, because I took all of this before, this is what I added below. So this whole thing added together is going to be my new denominator, which is at the bottom. This gives me 3x plus 4 all over x times x plus 2. All right? So now to deal with this, my top fraction divided by my bottom fraction, if I give you an example like 4/6 divided by, let's say, 2/3, remind yourself that when you divide two fractions, you keep your first fraction as it is, right? So 4/6 stays as it is. You actually switch from division to multiplication, and you flip the denominator. So you're flipping the denominator. At this point, whatever you can cross-cancel, you can. So this becomes 2. This cancels out and gives you 1. 3 goes into 6 2 times, 3 goes into itself 1 time. This actually becomes 2 over 2, or 1 is your final answer. So the idea is when you're dividing fractions, you take your first fraction, the top numerator fraction first. It's being divided by your denominator, which is 3x plus 4 all over x times x plus 2. But when you divide a fraction, your first fraction stays the same. You change division to multiply, and you flip the second fraction all over 3x plus 4. Wherever you can cancel on your diagonals. Whatever you can't cancel on your diagonals, you combine again. So 2 times x is 2x all over 3x plus 4. And that is your final answer. So a lot of work, but the idea is this final answer in simplified form is the exact same as what we had as our given as our original. But this is a lot easier to deal with in real life as well as in mathematics. This is a lot easier to deal with than this whole thing over here. So the idea is you simplify to make things easier. Even though it may be many steps and it may be looking very messy as you start cleaning this up, the idea is that your final answer should be in a more simplified form than your original. At this point, you have 4 practice problems that are part of this packet. So why don't you guys work on numbers 1 through 4 on your own, and the next time we meet in class, we can go over these questions together, go over the answers together, and make sure we're all on the same page before we move forward with these rational rational expressions.